Okay, let's continue looking at hypothesis testing for proportions. So we just finished this last example where we wrote the null and alternative hypothesis for this claim that John's free throw shooting percentage is 85%. And so we looked at how to write that. And then step 3, right, of our process, which goes back to our 5 steps of running a hypothesis test. The third step is to check requirements, right? So we've done this before with other procedures in this class, and you'll see very similar requirements: independent, random, and large enough. And that's again because it goes back to these are related scenarios, looking at standard error, sampling distributions, all of it's connecting together. And so we have the same requirements that n is less than 5% of the population size. It's related to independence, right? The events are independent. You have random, that you have some random process, right, to collect the data, and then it's large enough. So we're talking about proportions. We're looking at n times p is greater than or equal to 10 and n times q. So we're looking at that. And now to continue with this hypothesis test, after we know the requirements are checked, what we look at is the next part, step 4, is we actually have to calculate a test statistic. And for a proportion hypothesis test, we calculate a z-statistic, right? A z-statistic, test statistic, is similar to a z-score, where a z-score measures how many standard deviations away a value is from the mean, right? X minus mu divided by the standard deviation. For a hypothesis test, when we're calculating a test statistic, right, we're going to go ahead and calculate how far the sample proportion is from the population proportion, and then divided by the standard error. We're testing to see how many standard errors, because we're looking at, again, a sample, and we're looking at a sample distribution, right, with this scenario here. And so once we understand that's what the value is measuring, then we realize that when we have z values, we can calculate probabilities with them, which can be our step 5. But let's take a look at an example here, again, related to the free throw percentage one, right? If John shoots 74%, how far is he away, right? How many standard errors is he away from his claim of 85%? Well, the sample data is 0.74, 37 over 50. And then you calculate it, you can see we're just substituting right into these values here. Okay, we're substituting right into those numbers. And again, they're all connected back to our original writing our hypothesis here. And so with that, we end up with this value. Now, what is this value? This is a test statistic. We're going to use that to test to see what is the probability, right, that John would shoot this value, right, 74%, or something even less than that, right? What's the probability of that happening if he really is a 85% shooter? And so the next step is to find the p-value within this situation. And so to find a p-value, which is called the probability value, as you can see here, the p-value is of a hypothesis test is the probability of obtaining the observed value, right? In his case, 74%, or more extreme, or in this case less than, given that the null hypothesis is true, given that he actually is an 85% shooter. This is a conditional probability. Now, to calculate this p-value, it's a normal calculator. It's a z-score, and you go ahead and calculate that. What is the probability that his z-score, right back here, would be negative 2 point, right, less than or equal to negative 2.18? And to do that, that's, again, that would be calculator, normal, and we want that it's less than negative 2.18. And then you can see you get this value here, 0.014628. You can see that's where, let me write it in there actually. So it's point 0, going back to, let's make sure we get this accurate. Right, 0.014, 0.015, we'll round, right, to 3 decimals, 0.015. And so now we've calculated this value. This is the p-value. And this p-value here, right, where we just calculated for this test statistic is 0.015, which is related to 1.5%. Now, what do we do with that p-value? Well, it helps us determine if something is statistically significant. This is a very important word in statistics. And it's statistically significant, this data that we collected, right? If the result is unlikely to happen by pure chance, meaning that there's a low probability, right, of this happening, a low p-value. And so you would have to think about what is low, what does it mean, which is here, right? How small of a probability is too small or low? And so something statistically significant if we get a low p-value. And again, what we're trying to measure back is the original claim right back here that he said he was an 85% free throw shooter. He could make it, but his sample was only 74. And so we're trying to verify, right, does the data tell us that he's, is there evidence to show that he's 85% shooter or that he's less than, right? That maybe it's less than. And so once we have this data, this p-value tells us that it's a low chance that he would shoot that percentage if the null hypothesis is true. And so how low is too small or what's too small? It's our level of significance. And normally we compare a p-value to 5%. That's normal, right? We call this the level of significance. But we use other ones. I mean, sometimes, again, depending on the scenario, we can use 1% alpha 0.01 or alpha 0.10. And so then that's what we would do. So in this case, is this significant is what we're thinking about.